Welcome to Integrated Math, our very first math lesson for this semester. And we're going to go to the PowerPoint now, and this is going to be a very directed lesson. We'll be doing our live lessons starting next week. Will be extra credit since it's a second lesson for this week, but it is important for you to help you with the assignments that you'll be working through online next week before the next lesson. So let me get the PowerPoint brought up and we'll get started. Okay, so here is our first slide, and it's telling us we're going to be talking about systems of equations. Actually, we're just going to talk about substitution, not linear combinations today. That will be in a week. So here's our essential question. It says compare and contrast the two different methods for solving systems of equations, the two different methods we're going to be talking about today. And be sure to mention the pros and cons of using each method. I'll give you a couple minutes to get this written down and then move on. Once you have it written down, great. And don't forget that you're supposed to be taking these notes in Cornell note fashion. Also, if you don't get it quite written down, just wait till the end. It'll come up on the recording in a little bit, and you can go back and pick up the question from the recording. Okay, we're going to move on now. And so again, if you did not get this finished, then you can come back on the recording and get the rest of it later. So one of the things you need to know is that there's multiple ways to solve problems. And as we look at those multiple ways, you can draw pictures of what's happening. You can build it, you can use blocks and things like that, whatever might work to help you. You can make tables, you can draw graphs, you can write equations, and you can use words. And as we actually start doing our live lessons, I'm going to be asking you to do a lot of these kinds of things. And so take a peek at some of the things that we're looking at today because they fall under this category. I'm going to skip the next couple slides here because that would have been for a live lesson. All right. So as we start talking about systems of equations, we need to think about some vocabulary. And so here's a few vocabulary words that you're going to need to become familiar with. So go ahead and jot those down. Again, I'll give you about a minute or so to get those copied down. And if we move on, you can go back and grab them from the recording. Okay, I'm going to move on. Again, if you did not get them, you can get them from the recording. So if we're going to talk about system of equations, a system of equations is a set of two or more equations with the same variables. So you'll see some examples of that in a couple minutes. A system of linear equations, it meets the requirements I just mentioned, plus it has all equations when they're graphed, they form lines. So you've got two or more equations, and those equations all form lines in a system of linear equations. That's why they say linear, because they're the lines. And the solution to a system of equations is or are, depending upon how many equations you have, the ordered pairs where the two or more equations share an answer or share a point. It's that one ordered pair point where the two lines or three lines or whatever it might be intersect. That's where they share an answer, and the x and the y numbers that work in both equations are exactly the same. So here's our first slide, and we have a system of equations because you can see we have two equations there next to the line, and it says y equals x plus 9, and on the black line and the green line says x plus 3y equals 15. And based on what we just talked about, we're looking for the solution that work for this system of equations, because we have two equations and they both graph and make lines, as you can see. And so we're looking for the place where the two equations intersect, and that's where they share a solution. So that black dot or point is where they share a solution. So the solution there would, reading the x value first, is -3, and then the y value is 6. So it would be -3, 6. So again, we're looking for the place where the two lines intersect, in this case, or any of those equations intersect to find the solutions. So what's one method to find the solution for a system of linear equations? Well, as you can see from before, we can graph the two equations and to find our solution. So what do we need to think about? Number one, we need to be sure the equations are in slope-intercept form so that we can graph them easily. Remember, if they're in slope-intercept form, it's very easy to graph. We know the intercepts, we plot that, and then we use the slope to move from there to the next point and get the next few points using the slope. Then once you have the slope-intercept form, then you're going to graph both equations on a single coordinate plane, and be sure you're using graph paper when you're doing this for accuracy. So in this case, they graphed both the equations on the same coordinate plane. Once you've graphed both equations on the single coordinate plane and you're using graph paper for accuracy, you need to find the ordered pair that the graphs share. That's where the lines intersect. So you need to stop and think about. Let's stop and think about for a second. If we're looking at something like this, what would the pros and cons be? What would the good things about this be and the bad things about this be as a method for solving our equations? So I want you to stop and think about that and jot a couple of your ideas down in your notes. Why might this be a good way to find solutions or find the solution? Why might this not be such a good way to find the solution? And I'm going to give you a couple minutes or a minute or so to think about this and jot it down. If you're watching the recording, then this is a good time to pause and think about it, and then start and get something on your paper, and then come back and start again. Okay, One of the things that is a positive actually about this is that you can very easily see the answer. It's pretty easy to quickly graph these two lines. And we're seeing the exact point of intersection, and we understand that the solution is a point of intersection. So it helped us understand where the solution is and what the meaning is of the solution. One of the negatives about this is what would happen if that point where they intersected was not at the intersection or on the actual intersection of the grid lines. What if it was in the middle of one of those boxes? Would we be able to tell the exact answer on this if we needed an exact answer? So think about that as one of your cons or your negatives. So if we're doing this, one of the things we need to do is the first thing we would need to do is we need to change our two equations so that we're both in slope-intercept form. And as you can see, the first equation is not in slope-intercept form. So the first thing you need to do is change that first equation into slope-intercept form. Now, as we go through that, then you're going to graph those two equations. So you'll have the first equation is y equals negative x plus 5. So the plus 5 is your intercept. So you're going to put a point at the plus 5. And then it said negative y. So you're going to go down 1 and to the right 1. So you end up with a negative slope. Then you keep doing that and make sure, don't forget, remember that I asked, did you have the line that you're creating going across both axes if it's going to do that. In this case it does. And then do the same thing with the other equation. You're just going to start at negative 1 with the point, and your slope is 1/2 x. 1/2 up there, it's not 1/2 x, it's just 1/2. And so that means you're going to go up 1 and to the right 2. So we have a positive. You're going to go a positive direction and a positive direction. So we have a positive slope. And you're going to do that until you get it graphed. So to take a minute or two to pause at this point and actually put those equations onto some graph paper in your notes. And see if you can find out where they intersect. And it's going to be very important to do it on graph paper or have some sort of grid that you're doing this on that you can include into your notes with that in order to find the accurate answer here. Okay, as I move forward, I will still expect to see the previous graph actually graphed in your notes, and so please make sure that you've paused long enough to take care of that and haven't just skipped forward. The next slide asks, what is the solution to this system? And it gives you actually two equations and then graphs them for you. So the solution here, notice that the lines are parallel and they never intersect. So because they're parallel and never intersect, there is no solution to this system, because remember what we talked about is the solution is where the lines intersect. And so therefore, that's not going to work in this situation. So if we notice this, we notice the lines are parallel, and if we think back to before our break, we found out that when in lines that are parallel, the slopes are the same, and you'll see that here. They both have a slope of -1. And so sometimes when we do math, there is no solution, and this is one of those cases, and we have to think about it and talk about it. So we have no solution when the lines are parallel in a system of linear equations. So here you get to practice that a little bit and see if this set of equations has a solution or not. So you're going to need to pause here and get your equations written down and graphed and see what you notice. Answer the question. So I'm going to pause for just for a minute or so while you work on finishing that, and you can keep your end paused as long as you want until you are ready to move on. I will again expect to see this graph graphed neatly on graph paper in your notes. I will also expect to see in response to what do you notice. So again, you actually should have noticed that these two lines end up right on top of each other. They are exactly the same line. So in this case, our system of equations has multiple solutions because any point you pick for x has the exact same y value no matter where you are. So this is a little different situation. Our first situation with systems has two lines that intersect at one point. The one right before this was two lines that were parallel and never intersected, so there was no solution. So we had one solution, no solutions, and now we have a situation where one line is right on top of the other, and we have multiple solutions. Any point that's on either of those lines works in both situations. We're going to skip this. Okay, so there's a second way to solve a system of equations, and that's called the substitution method. Based on what we know from before, we know that we're looking for the place where the two lines intersect. That's the place where they share an x value and share a y value. So that means the x value in one of the equations has the exact same value as the x value in the other equation. And the same for the y value. The y value in one equation is the exact same y value as in the other equation. So if those two y values are the same or those two x values are the same, then we're going to be able to replace one value for y with the other y value. So in this case, we have a y value of x minus 9. So when I see y in the first equation, I can replace that y with x minus 9 because that's the exact same value as y, and that the y in the first equation is exactly the same as the y in the second equation. So I'm going to take that and I'm going to put it in place of the y, as you can see in the equation that's already there and being worked. So instead of saying 3x plus 2y equals 2, I put 3x plus 2 times x minus y equals 2, because if you look back up at the top, the second equation says y has a value of x minus 9. It's exactly the same as if I was putting a number in, just a single number in there. Sometimes we would say y equals 5, and we put 5 in place of the y. We're doing the same thing now, except we're using an expression in place of the y. And then I just worked through and I solved the equation, as you can see. The only thing is, once you get down to the bottom, where it says x equals 4, we're not done, because when we have a system of equations, that means we have two variables. Or more. In this case, we're working two equations, so you have two variables, and so we need to be able to solve for both the x and the y when we solve this equation. Again, if you need to pause to get this copied down, go ahead and do so in the recording. So, what are the steps to solving a system of equations using substitution? So the first thing you have to do is solve one of the equations for either x or y. In the previous sample, one of the equations was already solved for y. But if it's not, then just go ahead and solve one of them for y. or x. It doesn't make a difference. It can be one or the other. Substitute the expression for that variable into the equation and then solve it. Then you substitute the value of the found variable into the other equation, not the one you just finished working with, but the other equation, and find the value for the other variable. It's really important that you don't use this exact same equation that you used to solve, because you need to make sure that you didn't make a mistake somehow. So if you use one equation, then you need to pick the other equation to put your answer into to make sure it's going to work and come up with the correct answer. All right. Actually, that's when you're checking and check your solution. All right. What do our special cases of what we call coincident inconsistent classifications look like? So in other words, when there's no solution or when there is multiple solutions. And so here's a situation where I have two equations, and we have a definite y equals 1/4 x plus 5, and then you have a 4y equals x minus 8. So I know what y is. So it's very easy for me to replace the y in the second equation with the 1/4 x plus 5, because it's already telling me that that's there. I like that too, because when I multiply 4 times 1/4, as you can see below, I'm going to get 1 and then get rid of that fraction. So I replaced the y in the second equation with the 1/4 x plus 5. Then I multiplied that out using distributive property, and I solved the equation. And when I solve the equation, you'll notice that the x's go away, and I get 20 equals -8, which is not a true statement. So when we get something like that, where it's not a true statement, then we know there is no solution. The only time we're going to have actual solutions is when you have a true statement there. Again, if you need to pause, go ahead and do so. Remember, we also had the situation where there was multiple solutions. And so here's a situation where there is multiple solutions. And it's nice because the second equation here says x equals y minus 5. So in the first equation, I'm going to replace the x with the y minus 5, and you can see that in the work that I did. So I end up with 2y equals 2 times the quantity, y minus 5 plus 10. And then I multiply that out and work it through, and I end up with y equals y. And if y equals y, that means that no matter what value I choose for y, it's going to work in both equations. So that means I can have multiple solutions that are going to work. And so therefore, this is a place where the two equations are exactly the same. They just look a little different. And so we'll have multiple solutions. Again, feel free to pause and then restart if you need to continue to copy this. So basically the last question that you need to think about and work on and have some answers to is, what are the pros and cons of the substitution method? What are the things that are good about the substitution method, and what are the things that aren't so good about the substitution method? When is it going to be best when you're thinking about substitution versus the graphing? When is it going to be better to use substitution than graphing? When is it not a good idea to use the substitution method? When is that going to be a lot more challenging? And maybe you want to see if we can find even another solution, which we're actually going to learn about more solution methods the following week, next Friday. So see if you can think about these and come up with some answers that you might be able to look at and we can discuss next Friday as we move forward with our next lesson on next Friday. So with that, we are done, and hopefully everybody has a nice weekend. It's a nice long weekend, and good luck as you work through your work. If you remember, if you have any questions as you're working through your assignment, please just send me an email or get a hold of me somehow. Thank you very much, and have a nice weekend.